Hello, and welcome to Using Arcade in ArcGIS Field Maps. My name is Doug Morgenthaler, and today I'm joined by my colleague Chris Dunn. So what are we going to cover in this session? We're going to provide a brief overview of ArcGIS Arcade. We're going to talk about how Arcade comes to life in field apps today. We're going to go through some demonstrations to show you how you can get started with ArcGIS Arcade in our field apps. We'll take a deep dive into advanced arcade functions, and then we'll wrap up with tips, troubleshooting, and some resources to keep you going. So what is ArcGIS Arcade? ArcGIS Arcade is a lightweight cross-platform language. It's not a full programming language though, and it's really meant to be very simple. Easy to use, easy to get started with, but also very powerful. It's portable. It's used in a number of places throughout the ArcGIS system, including our web applications, our field apps, and desktop apps as well, like ArcGIS Pro. It's designed to be secure so that you can trust that the access provided by Arcade doesn't compromise the security of your operations. And finally, it's inherently geospatial. There are many ways that you can directly manipulate and access GIS information and query using spatial methods. So what are some of the benefits of ArcGIS Arcade versus other methodologies? Well, first, again, it's meant to be very easy to get started. Some expressions may only be a single line. As you see in the examples here, both of these are very, very straightforward, a couple of lines of Arcade code. It's meant to be calculated on the fly. So I don't need to spend a lot of time doing pre-processing. I can continue to iterate and use data and know that as that data might change, Arcade is changing and interpreting that in real time. Finally, because it's calculated on the fly, there's no schema required, so I don't have to calculate a new field. And of course, by not having to do that, I also don't need to worry about owning the data and being able to make changes to that schema. Arcade works in a number of our field apps. That includes our newest product, ArcGIS Field Maps, which offers the most robust opportunities for taking advantage of Arcade. But it also is available in some of our other mobile apps, including ArcGIS Collector, Explorer, Workforce, and the like. Arcade also works in both web maps and mobile map packages. So if you're taking advantage of either of those, Arcade is available to you. And finally, Arcade is available and Arcade expressions are evaluated whether you're working with a connected map or you're working completely offline. Arcade comes to life in a number of different places in our field apps. One is Symbology. You can define a renderer based on an Arcade expression and control the Symbology's transparency and its rotation for point symbols. You can provide quick access to information via labels that are well formatted using Arcade. You can provide a wealth of information via pop-ups using Arcade expressions. And you can also streamline field data collection using form conditional logic that's based on Arcade as well. Let's take a look at how you can get started with ArcGIS Arcade in our field apps now. All right, here we are in ArcGIS Field Maps. This particular map is designed for capturing and using weather observations, specifically those that might be useful for understanding potential fire behavior. You'll notice we have some different colored observations, so some are red, some are blue. Those are indicating which ones of those have been more recently entered, i.e. in the last 12 hours, and other ones are not. As we zoom in, we can see that there are also labels that give us immediate access to key information. In this case, a formatted label showing us the relative humidity at that observation, which is 30%. If we tap on the particular observation, we'll see that it has just a bit of information. It has the dry bulb and wet bulb temperature and the relative humidity. Well, let's go ahead and zoom and collect a new observation. You'll also notice in the pop-up title that there's a formatted date. That formatted date uses a specific time format that is most useful for the mobile workers who are using and entering information using this map. So let's collect a new location. We're going to enter just two values, a dry bulb temperature and a wet bulb temperature. And once we've completed that, we'll go ahead and submit our edit. And you'll see that if we expand the pop-up, you'll see that the relative humidity was automatically computed. Let's take a look at how this particular map was optimized using ArcGIS Arcade. All right, so let's take a look at how we went about creating some of those capabilities using Arcade that we saw in Field Maps Mobile. So the first thing we're going to do is we're going to define our symbology using Arcade. So you can see here we've got a single symbol renderer right now. We're going to go to our styles and we're going to define an expression. That's going to open the expression editor. And we're going to give our title here and say within 12 hours. So that's basically, we want to represent those symbols differently for those observations that were newer or older than 12 hours from the current time. So on the right-hand side of the expression Arcade editor, you'll see that we have some globals. Of course, this is things that are tied to our feature, functions, and constants. We'll go ahead and start with a function. So we're going to type in date. You can see we have a number of different options. We have date diff, and the date diff allows us to subtract two dates and return the value in a given unit. So you'll see here that it supports hours. So we'll use hours in our example here. We'll select date diff and we'll go for our ending date. Again, look for another function, now, the now function, and that returns the date in local time. So we want to always have this computed from the current time. Then we want to look at the starting date. Now we're going to go back to our globals and we're going to use our feature to replace the starting date with the creation date from our feature. So this is a field on our feature or part of the editor tracking fields. And then again, for age units, we're going to say hours. Okay, and we're going to set that to a variable. So again, we can define our own variables. Just for clarity, you can certainly tab to wrap lines between, so that it makes it a little more readable in the editor. All right, now we're going to use our elapsed time to determine what we hand back. So we're going to use, again, we want to know hours before, within, and beyond 12 hours from the current time. So we're going to use the if function. And again, that's going to allow us to do some conditional logic. So we're going to say the conditional expression is the lapse time is less than or equal to 12. So again, those are 12 hours. And then value of true is recent. And value of false is older. Okay, so now we're going to return that from as the result of our expression. So once we've done this, now we can test it. So we'll just see what we get. So you can see, okay, well, so it grabs a feature from our data set and tests that and returns a result. So in this case, it's older and it's being returned as a string, which makes sense. Now, one thing from a debugging perspective that you can utilize to test your code before you go back into Field Maps or another app is you can go into the creation date here, and I'm going to tap on the little pencil icon, and you can see that it allows me to set a given date and time. So I could set a given time and say it's today, and then I test that again. And now you see that that time is more recent, so it returns the recent result. All right, so now our expression's done. We're going to hit OK, and you can see that our renderer has changed here. We're going to just increase our symbol size a little bit. We'll go with 14. And now our older is in red and our more recent are in blue. So that's an example of how you can use an arcade expression to generate effectively a field that we can render against. And that's a virtual field, so I didn't have to actually change my data in order to do that. All right, so the next thing we're going to start working on is our pop-up. So if you remember, our pop-up had, you can see we have an example here, so it had our dry bulb and wet bulb temperature. But it also had some additional information in our pop-up title. So we're going to go and work on our pop-up title here. So you can see right now it's just a static string, weather observations, which is the name of the layer. So we're going to just modify that a little bit. And then we're going to tap on our curly brace icon here to define what field we want to use. But first, we want to go into our expressions. You can see we already have an expression here already defined. We'll get to that and use that a little bit later. But right now we're going to create a new expression. And again, this is going to open the expression editor. We're going to give our expression a name. So we're going to say 24-hour time. So in this case, people that may be using this map are used to getting their times in 24 hours rather than a 12-hour time. So we're going to create a very simple expression here, and we're going to use the text function. And if you look and see, so this converts an argument into a string and optionally formats it. So you'll notice some of the formatting options are around days, how we do days of the week, days of the month, and also time. So you can see that here we have military hours padded. So we're going to go back and use our text function, and we're going to go back to our globals and go to our fielder value. And again, we're going to go into our global, which is that feature, and use the creation date again, and we're going to specify our format. So we want abbreviated month format and a single day, and then we want the 24-hour time. So that was hours and minutes. Okay, so again, we're going to go ahead and test that. You can see now we've got our formatted date time. So I didn't have to make, again, I didn't have to make any changes to my data in order to present this in a way that makes sense for the users of this map in Field Maps. All right, so now we're going to go and exit our expressions, and we're going to come back to our title, and we're going to insert our 24-hour time. So again, this is an expression. You can see that it's listed just like any other field. The difference is this is effectively a virtual field that we can make use of. So now once we hit OK, you can see that Now my pop-up title lists that information, and you can see that it lists it in a 24-hour time format. Okay, now we did have one other expression here in our pop-ups, and that's relative humidity. Now we've looked at a couple of relatively simple expressions. Let's take a look at a little bit more complicated one. So this particular arcade expression allows you to compute the relative humidity given a few inputs. So we looked when we created the feature in Field Maps, we captured both the dry bulb and the wet bulb temperature using our form. And then there's some additional information that we're drawing from the point feature, the location in which that feature was collected. So we're going to get its geometry. Again, Arcade is designed to be very spatial, obviously for a GIS capability. And we're going to use, again, our global to get the geometry of that feature. In this case, it's a point. So I know I'm returning that as a point. And then from the point, I'm going to get its Z value. So this feature layer is Z aware. So this would have been coming from my GPS. And so that altitude would be populated. And then as we move down, we see we have a couple of functions. These are user-defined functions that compute various components we need to compute the relative humidity. So in this case, there's a function for barometric pressure with some constants and some expressions that need to be evaluated for the barometric pressure. Similarly, for the relative humidity, and you'll notice here at the bottom, this is where the actual call is made into those functions. So relative humidity passing in the dry bulb temperature, the wet bulb temperature, and the altitude. And again, so we can just do a quick test there and see that we're getting a number. Okay, so that's a very large number. So we'll deal with that here in a minute. But we want to present this information in our pop-up. So we're going to go back out again, and we have in our pop-up, we have a set of attribute fields that we're listing. So I'm going to just expand that. You can see that right now we're showing the dry bulb and the wet bulb temperature as evidenced by our example up here. And we're going to go ahead and say we want to select some additional fields. So in this case, we want to include the relative humidity. So there's our relative humidity, and you see that right now it's 26.51. All right, and again, it's just treated as a regular field for the purposes of inclusion in the pop-up. Now, we do want to format that. Generally, relative humidity is just in percent. So in our field configuration, you'll see our standard fields, creator, our dry bulb and wet bulb temperature that are part of the data, and you'll see our expressions are also listed here. So I can format expressions just like I can other fields in my table. So in this case, we're going to switch this, and we're going to say we want to show that at 0 decimal places, and we just want to give an indication here that this is in percent. All right, so now we've got our relative humidity, we've got our date time in formatted units that make sense for us for this use case. So I think we're done with the pop-up, but we do also want to have some labels. So now let's take a look at how we can compute labels using ArcGIS Arcade. So the first thing we're going to do is we're going to enable labeling on this layer. You can see that we have a label field, but I can also, again, go and define an expression. So in this case, if you recall in the mobile app, we had relative humidity. Relative humidity is a function we've already defined. I could, of course, copy and paste that in here, but I can also use existing arcade expressions that are already defined and place that and help me build my new expression. So here, and I can just tap I and see that this looks exactly like we had before. So we're going to go ahead and add that in. And now we've got we can test that again. So we've got our expression to calculate the relative humidity, and you'll see we're back to our really long formatted number. So there's a couple of things we can do. One, we can just come inside our example here and say we're just going to, again, for a label, it's going to be effectively a string. So we can say with our text, we want to just have that with no decimal place, no digits after the decimal place. So let's take a look at what that gives us. All right, so that gets us back to our round number. And again, you could have used a function like round also to do that. All right, now we also had some formatting around our labels. So the next thing we're going to do is we're going to change this and use a variable. And we're going to use that label or that variable when we build an expression that we're going to return with a formatted string. All right, so typically you would maybe put RH as an abbreviation and concatenate this with relative humidity variable and finish that off with a % sign. So let's test that. Great. All right, so that works. So it gets us back to where we want. One of the new capabilities that has been added to Arcade recently is string template literals. So effectively, that allows you to create a string without having to append all of these pieces together. So it's a lot easier to read, especially for longer expressions and write. So we're going to convert this really quick, and we're going to start removing some of the things we don't need. And when you're doing template literals and you want to reference a variable, you do a $, and then close the variable in curly braces. You can get rid of the plus sign and all the quotations, and again use another backtick to define that. So let's test that again. And you can see that our value is the same. So now, if we come in here, you'll see that our relative humidity is being shown using our templated string. So those are some examples of how you can use ArcGIS Arcade to optimize how your map looks and behaves for your mobile workers to optimize their workflows while they're out in the field. Let's take a look at another example of how you can use ArcGIS Arcade to optimize the information that's presented in the pop-up and how that information can be collected in a form. All right, we're back in ArcGIS Field Maps Mobile. And in this example, we're going to open a map that's designed for collecting water samples. When we tap on a particular well, we'll see that we get some information for that well, but it also has related inspection tables. The first one is chemical analysis. So we're going to open that, and you can see that we have a previous inspection. Let's go ahead and look at that inspection and pull the form up, and you'll see that the pop-up has a really rich set of information. So it outlines each characteristic that's been captured, defines its value, and then on the right-hand side, on the threshold, it gives a visual indicator, either a red or a green bar, of whether or not it's inside or outside that threshold. So great way to visualize information once you collect it. Let's start a new observation or a new inspection, and you can see that I have a very simple form here. First thing I need to do is determine whether or not the site is accessible so that I can complete an inspection. So if I say no, in this case, you'll notice that I get a comments field that's displayed where I need to specify why I can't get in and perform that. But if I say yes, I now see information that allows me to capture all of that specific measurements and complete the inspection. And you can see those are expandable and collapsible groups, so I can manage the form. So let's take a look at how you can build a pop-up that provides a really quick summary view of the sample and inspection and its comparison to thresholds, but also how you can create a really intelligent, effective form for collecting that information. We're back in the new map viewer, and we're not going to spend a lot of time in here, but I did want to highlight another way that you can utilize Arcade. So here I've got, of course, my wells layer, and I also have a couple of related tables associated with that layer. So one of those tables is a chemical analysis table. So if we have a look at the chemical analysis table and we look at its pop-up, you'll see that this is a custom pop-up where each of the characteristics that are to be sampled show the measurement, but also show a nice indicator showing whether or not it's within an acceptable range. So green being acceptable, red out of range. So gets that quick visual cue as to which items are of concern and may need remediation. Now, how was that built? Well, each of these elements in our pop-up, these swatches, were built with Arcade. So if we go and look at our expressions, you'll see we have a number of expressions here. So we'll just take a look at one of them quickly. We'll look at pH, for example, and we'll open our editor, and you'll see that if we have a look here, we'll see that's just a very simple if statement, conditional logic to see if it's higher, the pH is higher than 8.5 or lower than 6.5, then we would show one color swatch or another color swatch in our HTML table. So again, green and a red and green. So if it's outside that range, we would show red, inside green. So each of these uses a similar pattern to help generate that. Obviously, the numbers that are used to determine whether or not it's an acceptable range differs by particular characteristic that is being sampled. Okay, so we've seen how you can use that in the pop-up. Let's take a look at the form aspect. And for that, we're going to go to Field Maps Web. So Field Maps Web is a new web application that's designed to configure, author, and help deployment of forms for field data collection. So again, we've got our same web map here. We'll go ahead and open that. And again, I can go into my content. You'll see I have my editable layers, and then I also have my tables. So we'll go ahead to our chemical analysis table, and we'll look at our form. So there's some elements of our form that are already defined. So we have a couple of groups that have defined for physical properties and bacterial characteristics that would need to be captured. But we want to, if you remember, we have some behavior around that information. So we had a field called site accessible. So we're going to just drag that onto our canvas. And the site accessible is, we're going to make that required. And so based on whether the site is accessible or not, we can determine whether or not we can actually perform the water sample and complete the inspection. So if, for example, we weren't able to complete the inspection, we would need to enter some comments. So that comments field showed up. So again, we're going to make our comments field required, but we're also going to add a conditional visibility expression. And this is, again, where Arcade comes in. So that's going to launch our expression editor. And in this case, we're just going to say if the site is accessible, then we want, or if the site is not accessible, then we want that comments field to be displayed so the field worker, the mobile worker, can enter that information. And again, we can test those things as well as we saw in earlier examples. So we can apply conditional visibility for specific field. We can also apply expressions to groups. So if, for example, the site isn't accessible, there's no need for me to show the physical and bacterial characteristics for someone to enter. So in this case, for the whole group of my physical properties characteristics, I'm going to define, again, a very simple arcade expression where the site is accessible. And again, we're going to do the same thing for our bacterial group here in the domain name. Yes. All right. And again, these are, you can use the editor to define whether those are visible or not. All of these expressions must evaluate to a Boolean value. So this is using the constraint profile. All right. So once I'm done with that, I can just save my form, and voila, we've got an example of how you can use Arcade to conditionally make fields or groups of fields visible in your data collection forms. With that, I'm going to go ahead and turn it over to Chris for a deep dive into some more advanced capabilities of ArcGIS Arcade. Chris?
Thank you, Doug. So the main thing I'm going to be talking about is a set of arcade functions called feature sets. So there are several functions that will return a feature set, and a feature set is exactly what it sounds like. It is a group of features consisting of a subset or the entirety of a feature layer. The feature set can contain the table, the geometry, or both, and it can be filtered both spatially and using the attributes depending on how you call it and which other functions you use in conjunction with that. So what I mean by that is if you are calling a feature set and you are buffering around a point, then you can call all of the features from a different layer that intersect that buffer around that particular point. So that is what makes feature sets incredibly powerful for authoring web map pop-ups, is that you can configure a pop-up for one layer, but pull in features from a different layer to use as the feature set. This turns Arcade into a full-fledged geospatial analysis tool, all within the context of creating pop-ups to use in ArcGIS Online and ArcGIS Field Maps. So I'm actually going to just jump right into a demo and show you a little bit about how this works. Here I have a map with quite a few tree locations, and these points have a related table with inspections, and those inspections all have a pass-fail value. So using Arcade, I have set it up so you can select a tree, you get some information about the parcel that the tree is in. Then when you pick the tree, you can see the last inspection date and the number of failed inspections. So this is tree B06. Let's add a new inspection. Let's call this report 1, tree B06. Date is today. And I will call this a pass. I'll submit that. And then when I go back into the pop-up, you can see that the last inspection date has changed to today's date. And this is all fed live from the inspection table using Arcade and the feature set by relationship expression. So let's jump over into the Arcade editor in ArcGIS Online, and I'll show you how that works. So here I am in my tree inspection web map, and as you can see, if I click on that same tree, I will get my parcel information in the pop-up title, and I can see my inspection date there. So I will show you how I used feature sets to populate the parcel information, the last inspection date, and the number of failed inspections. So we can take a look at our pop-up configuration, and you can see I have 3 arcade expressions here. The one I'm using in the pop-up title is this expression 2, so let's take a look at that. So this uses the intersects expression, and you can feed that 2 different geometries, and it will return the intersection. And in this case, I'm using the global feature for the tree that I'm clicking on or tapping on, and then I am using feature set by ID to call the parcel data, which I have in the map, but I'm not actually showing. But I can still call it using the ID, and then that will return the feature set, which contains the parcel that intersects the tree that I clicked on. And when you use feature sets, because it's a set, treat it kind of like an array. Even if your expression only returns a single value, you still want to use first to pull that value out of the array. And then my parcel becomes a variable that then I can then pull use the map book lot field to pull the parcel information out of. If you want to see the full feature set instead of just that one field, this console command is really useful. So what that does is it can send messages or data or results or anything you want to the console instead of as the result. So here you can see the actual geometry from the feature that's returned in the feature set and the attributes here at the end. And this is a good way to see the difference between just returning the feature set, the I parcel, or pulling the first one out, because if I just do console I parcel, which was the result of my intersect, you can see that's just returning the object, the feature set itself. So this one's a relatively simple use of feature sets, just intersecting 2 layers and then pulling an attribute from the intersecting layer but bringing it into the pop-up of the first layer. So let's take a look at one that's a little more complex. So if we want to look at the number of failed inspections, it's still fairly simple. So this is actually using the filter function instead of intersects. And this is using feature set by relationship name. So the inspection table is related to the tree points. So you can use that relationship to draw data and attributes across that relationship into the pop-up. So I'm using feature set by relationship name. I'm using that global feature for the tree that I'm selecting, and then the name of the relationship is tree inspections, and then I'm filtering it just using the pass-fail field in the inspection, and it's a coded value domain. So I use 2 to represent just the inspections that are a failure. And so this related records variable is used here with count, which just returns a count of the rows in the table, and then I just get my inspection count. So that's pretty straightforward, but it's a different use of feature sets because it's using that relationship. So you have to have a relationship set up between your point and your table in order to use this function. And then the final one for the last inspection date. So this expression also uses the feature set by relationship name function because we're using the same table of inspections. But instead of just filtering the table, I'm using this order by function. It's ordering it by the inspection date. So you can see I call the feature set by relationship name on the feature with the tree inspections relationship, but here I'm passing in the SQL command to return the values in descending order by the date field, which is the inspection date. So that will ensure that when I pull the first record out of the feature set, it will be the most recent inspection. If I want to double check that this is working correctly, I could always use that console command again. So I can define a quick variable then do a for loop where if I look at the row in the related records, then do some curly braces. So for each row, I'll send to the console the row.date field. And then when I test that, you can see I've got May 10th, May 3rd, April 26th. So that's the first record is going to be the most recent inspection. And remember again that here date is the field. It's not like a date function or anything like that. So then I just declare an empty string for the, here I call it related info, just the information from the related table. And since some of the trees don't have any inspections, I'm first checking to see if the count of records in the feature set is greater than 0. If so, I pull the first record from that table because it's already been ordered using that date descending command. And then I just format it using the text command and return it as the related info, which becomes the value for the pop-up. I also check to see if the count of records in the related feature set is 0. And in that case, I just return a text string of no inspections. If I were to use that first function on a feature set with no records in it, it would return an error because it's looking for something in the feature set, and it expects there to be a value, and there's no first value if there are no values. So that's why I do this check here. So now let's move on to the final demo showing how to categorize intersecting points within a polygon. So here I am in a new map. This contains town boundaries for the state of Maine, as well as points from the USGS Geographic Name Information System, or GNIS. These points are just features that you'd see on like USGS quadrangles, things like trails, streamheads, summits, cemetery, buildings, all sorts of different features that have been recorded over the years. And let's say I want to create a pop-up for the town that will summarize all of the points by those categories within each town. So in order to do so, I can use Arcade feature sets to call that GNIS point layer, and then use a function called group by to summarize them and get a count for each type of feature. So let's add a new expression. And so I want to intersect my town feature with the GNIS points. So I'll call intersects. And I'll use that global feature. And then I'll intersect it with the feature set, calling it by name. So I will pull it in from the map. I have GNIS points, and I'll just use feature set by name to pull that in. And I'll move it down so it's a little more legible. So that gets me my feature set of the intersecting points. And then I want to group that feature set by the values in that feature class field, which tells you what type of point it is. So I'll just call this X to make it a little easier. So I'll use group by. I will use that town GNIS feature set. The field I want to group by is feature class. And then for group by, I need to pass the name of the expression I'm creating, a value for it, and the statistic. So in this case, I'm just going to call it, I need my curly brackets, call it name, call it GNIS. And then because I am just counting each record, I'm just going to use an expression value of 1. If, say, I had a field that I wanted to get an average of, I would use the field name here in this expression value. You could also say, if you're dealing with like percentages, you could do that field divided by 100 or multiplied by 100, and then apply a statistic on top of that. So the statistic is count, and that's closed off. And then let's verify I did that correctly. Let's check out the console. And I'll just do a count of the records in X. So let's test that out. I don't have any results because I'm not returning anything yet. But you can see that I have 12 of one type of feature class and 12 of another. So hopefully my final pop-up matches that for the town that I'm looking at right now. So now I want to build my pop-up using a for loop like I did in the previous example. So I can just define an empty variable for the pop-up. And then for my, I need to define the row as well, for row in X, popup plus equals row dot feature class. Then I'll add a little dot, and then I need to pull in that GNIS. Oh, sorry. Plus row dot and then GNIS, which is the name of the kind of the new statistic field I created. And then add a new line. And this text formatting.newline is an arcade function. And let's just make that a little bit easier to read. Okay. Then I'll just return that pop-up. And now you can see a list. Okay, so I had 12 different feature classes. That, I had the wrong, I was thinking of the wrong thing here, but that makes sense. I have 12 different feature classes in this table. So you can see, what the pop-up will look like. I could also have used order by like I did last time if I wanted to rearrange this so that it is the most frequent feature class at the top rather than having it be alphabetical. So then I just need to add that to my custom attribute display. So I have GNIS summary for town that's pulling from the town field, and then I've actually already included this expression which you can pull from here in the pop-up. So when I go to click, I'll get my list. And then I will jump on over to Field Maps to show you what it looks like there. So here we have that same map in Field Maps. You can see my town boundaries and those GNIS points. And if I tap on a town, I get that pop-up, and it summarizes all of the GNIS points. You can see there's quite a few cemeteries here. So yeah, that's just one example of one of the many ways you could use Arcade in Field Maps. Specifically, Arcade feature sets. There's quite a bit you could do with these. For instance, You could use it for workflows where you want to validate your data. Like let's say you have culverts with a culvert ID that's associated with a road. So the road ID is included in the culvert ID. You could set up a map where if you tap on the road feature, you get a list of culverts that have mismatched culvert IDs, and then you could, go make sure those culverts are recorded in the correct place in your data set. Or you could use feature sets to call a last known location layer from Tracker and see which features your field workers have passed by recently, or who is closest to which feature that you need somebody to go inspect. So there's quite a bit you can do with feature sets, both for web maps and for field maps. It's a very powerful tool that I look forward to seeing what everybody does with it in the near future. And along those lines, we do have kind of some tips we just wanted to summarize of things that were shown kind of during the presentations and the demos. Definitely use that test button in the arcade editor as well as the console. And when you're looking at the values that are returned when you test, check the return type, whether if it's a string or a number, because that will affect how it displays in the pop-up and the options that you will have in in the regular pop-up editor or that pop-up configuration. You can define specific values when you hit that test button. I know Doug showed that in his demo where he picked the date. You can also put in attributes for a specific field, so you can have that expression then test against that one specific feature that you want to test it against. And if you're doing something complex like calculating relative humidity, obviously you want to use functions to keep that code kind of encapsulated and easier to manage. And use string literals for concatenation just makes things a bit easier, which Doug showed, even though I didn't do that in my demo. As far as field maps specifically goes, the date in numeric, field formatting is not driven by the pop-up definition. There are geometry limitations, so you want to make sure your spatial reference is the same for all of your data. And if you're doing some tasks with geometry, if it will depend on the scale, so you don't want to be zoomed too far out, whenever you tap on your feature. And if you're using smart forms, that conditional visibility has to evaluate to a Boolean value, so you want to make sure that's coming out as true or false. So the road ahead for Arcade, there'll be more that you can do in forms with field calculations and some new authoring experience for conditional expressions, which will be a little bit more of a almost like a visual scripting, like you won't have to write as much Arcade. There'll be components you can use to represent that, and a redesigned editor for the Arcade expressions in the web map, plus attribute rules will be coming to Arcade. I know that's something that people have been waiting for. And another feature set option is feature set by association, which is utilized by our utility networks. And when there is support in our runtime SDK for utility networks, they'll be adding support for feature set by association, in field maps as well. So there's some really cool stuff coming down the line. And here's a few resources. We have a developer reference, which has a full function reference and a kind of a quick start guide. It also has a version matrix, which shows you which versions of Arcade are supported across the platform, because there are a few little disparities there where Pro might support something that the runtime SDK hasn't implemented yet, so it won't work in field maps. So that's something to be aware of. As you're building your expressions, always test them in field maps, or whatever your final platform will be for consuming that expression, because you don't want to do a ton of work on an expression in Pro and realize it doesn't work in ArcGIS Online or in field maps. For the most part, things are kept up to date, but sometimes there are a few little functions here and there that don't make it fully supported across the platform. We do have a GitHub repository as well as a blog. There's some great blogs with all sorts of questions about Arcade and that are answered, and some demos and more context for some of this stuff. So definitely check out the blog. It's really, really useful. And that is our presentation. Thank you very much for taking the time. We hope you enjoy the rest of the Developer Summit. And if you would, please provide feedback for the session by clicking on the session survey directly below the video.